आ गया ना?
क्लिक ऑन दिस और यहाँ पर इसका ईमेल पेस्ट करना है। तो ये नीचे क्योंकि पहली बार जो सिस्टम है उसका वो नहीं रहता ना आइडिया, मैं तो उस वाले कीबोर्ड में तो ब्राइट है, बेकार में मैं ब्लैक एंड व्हाइट में जमाने में कर रहा था इंटरव्यू।
आ गया कॉल मारेंगे उसको।
Hello.
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 Yeah. Hello. Can you hear me? Hello.
Yes, sir.
Okay.
Yes, one minute.
Okay. Am I clear now? Hello. Hello.
Hello.
Can you hear me?
Hello. Yes, sir.
Okay. So, like you have specified in your profile that you can take mathematics. Up to which standard can you take mathematics?
Up to 12th standard.
Up to 12th standard. And which board, CBSE, ICSE, are you familiar with this syllabus?
Yes, yes. Familiar with.
Okay, familiar with this.
And engineering, currently I'm working with the engineering college, so I can take engineering students as well.
Okay, you can take engineering students also. Yeah, but mostly here we get the school students only up to 12th. So
Okay.
can you just recall any one particular topic or something so that we can start from that point?
Oh, we can start with the algebraic expression.
Algebraic expressions? No, algebraic expressions, I think it's in the 7th or 8th standard.
Yes, yes.
So want to start with 11th or 12th, or like middle school, 7th and 8th?
Then we can start with the sets, relations, functions.
Okay, sets, relations and functions and all those things we can start with. Yeah, if we want to start with that intermediate one. So in that relation and functions, we have two concepts are there. The first is the relation and the second is the functions. Can you tell me the difference between a relation and a function?
Relation and function. See, all the relations are not function, but all the functions are relations.
Yeah, all the relations are not functions, but all functions are relations. That is true. But what exactly, like, what's the criteria that we can say, okay, this particular relation is a function and a particular relation is not a function?
Okay, there are many types of relations. Say one-to-one relation, one-to-many relation, many-to-one relation, and many-to-many relation. So we cannot say that a function. We cannot say that a relation is a function. Suppose if I have two images for a single value, and for example, say f of x is equal to root of x. Then that relation I cannot say that it is a function.
Then it's not a function. Yeah. So like in relations and functions further, I think in their syllabus they get the questions based on to check the various types of relations, like whether the function is a reflexive relation, symmetric relation, transitive relation, or equivalence relation. So those type of things. Like suppose if we take any relation, suppose if I say the relation A is less than equal to B. The relation A is less than equal to B. Now
A is less than equal to B. Okay.
Yeah, A is less than equal to B, and we want to check whether it's a reflexive, symmetric, or transitive.
So A is always less than or equal to A. It is equal to A, obviously. So it is a reflexive relation. Symmetric relation, we can say A is less than equal to A. Yes, of course, it is a symmetric relation.
So what the means?
Not a symmetric relation. If A is less than equal to B, then not be less than equal to A.
So it's not a symmetric relation.
Yes, relation is reflexive.
Hmm.
It is transitive. A is less than equal to B and B is less than equal to C. Then we can say that A is less than equal to C.
A is less than equal to C. So it is transitive also. So these things they have in their relations and functions. Then the composition of the functions, all those things are there.
Yes.
Apart from that, after that they have the inverse trigonometric functions. Then in inverse trigonometric function, or not inverse trigonometric function, but any general inverse function. If say f of x is a function, then what conditions should it satisfy to have the inverse of that particular function?
For inverse function to be exist.
Yeah, for the inverse function to exist.
For inverse function to exist, uh, for every image, that relation first must be an onto function, I guess.
Okay, yeah, it should be onto function.
Then the inverse function is possible. If it is a bijective function,
Hmm. So
one and
bijective, yeah, bijective function means it should be
should
uh,
be a onto.
onto, you told, and one more thing is there in bijective.
Into.
Yeah.
Onto is one function and onto
Yeah,
function. So
one
function
function and onto
and
function.
onto
Function
is
should
called
be, yeah, either we can say that the function is should be bijective function or one onto, right? So
yes.
these things then yeah, then the calculus and all is there in 11th and 12th, like the derivatives, limits, integration, and all those things are there. Suppose yeah, there is something called the implicit functions, the implicit functions and explicit functions.
Yes.
So what's the meaning of this?
See, implicit is nothing but I can just tell you the example.
Hmm.
Say x plus xy plus y cube. This is an implicit function.
Okay.
It involves variables. And if I write y is equal to say x square plus 5x plus 6, so that is the explicit function.
So means how we can define, like or how we can explain to a student, like what should be the distinction between implicit function and explicit function?
I need to just revise all the basics now because I'm teaching to engineering classes
Okay,
now.
okay.
So, but I know that implicit function is whatever example I have given that I think
That is correct. That is correct. The implicit function and explicit. Then they have the differentiation of the implicit functions, and all those things are there. Chain rule is there, product rule, and all those things. Say, do you have a pen and paper with you just now?
yeah.
Yeah. Suppose if I write a function f of x is equal to square root of 10x,
Okay.
or no, I write square root of 10,
Tan square root of
yeah, square root of 10,
10.
square root of x, square root of 10, that is 10 is within the square root of 10, and instead of 10x it is 10 square root x.
It is sorry. Just recall that f of x is equal to square root of tan x.
No, it's not 10x, it is square root of 10 of square root of x.
Square root of tan into square root of x.
Ah, square root of 10 of 10 square root of x.
Is it like this? Can you
uh,
square root of tan into square root of x?
yeah, of square root of x, yeah.
Okay.
Hmm. So what will be the derivative of it?
It is 1 upon
Hmm.
2 root tan root of x
Hmm.
into sec square of root x
Yeah,
into 1 upon 2 root x.
1 over 2 root x. Or suppose if we have a function like Say if I write y is equal to x raised to the power 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 x till infinity.
Okay.
So what will be the
Okay.
derivative of this function?
X to the power x infinitely many times.
Yeah, infinitely many times. X raised to the power x raised to the power x raised to the power and so on.
Is x to the power x
Hmm.
into log of x minus I've just forget that it is the derivative of x raised to x will be it is x raised to x into log x plus one something I guess. So up to
Okay.
the infinity many times I'm not sure whether what
Okay,
will
no
be the
problem.
derivative.
We'll move further. Like then after that, they have the integration and all those things are there, right?
Okay.
Yeah, in integration in 11th, it's not there in 11th, but in 12th, they have only one application, and it is to find the area under the curve.
Correct.
Yeah, integration we use to find the area under the curve. Now suppose if we have two functions, say two functions, or say two parabolas are there. Say one parabola is say y is equal to x square plus 2, and another parabola is y is equal to minus x square plus 3, and we want to find the area between these two curves.
Y is equal to
Suppose
x square plus
yeah, x square plus 2, and the second one is y is equal to minus x square plus 3.
minus x square plus 3.
Hmm.
Okay.
So and we are
So
interested in yeah, finding the area between the two curves. So it's not like solving it over here. You can just tell me the steps what generally we can do to find the area between these two curves.
generally, while solving in engineering students, we can plot the graph first.
Hmm.
Then we can take the limits of the lower limit and the upper limits,
Hmm.
and by and solving the definite integration, we can find out the area under the curve for the given function.
Okay, so like in the integration, which function will be taking?
So area bounded by x square plus 2 and minus x square plus 3. Na?
Hmm.
Means which function we need to take to solve this? You
No,
want
no,
to say?
yeah, which function or what we will be using in that integration? What function will be using in integration to evaluate?
We can use double integration over dx dy to find out the area. Actually, that double integration over dx dy represents the area under the curve.
No, that represent, but in 11th and 12th, they don't have double integration.
But they don't have
That
double
one,
integration.
and that and all is there in higher standards. Maybe
Yeah, yeah. We
BSc,
can
MSc.
solve that by
Yeah,
double integration.
yeah, because the
I told
students
that.
at 11th and 12th standard, they are not aware of all these concepts.
Okay. So the area which satisfies the both, so it is x square plus 2 is equal to minus x square plus 3. So we can take the function as 2x square minus 1 is equal to 0. 2x square minus 1. We can find out the integration of
Okay,
2x square.
how you got that one?
Actually, the curve which satisfies both the equations, so I equate that both x square plus 2 is equal to minus x square plus 3.
Mm-hmm.
And then I'll get 2x square plus 1.
Okay, so then that one, and like you told in the beginning, we'll take the lower limit and the upper limit as the boundaries. Now the you told you'll plot the graph, and after plotting the graph, you find the point of intersection of the two curves, and those 2 points will take as the lower limit and the upper limit, right?
Yes.
But
Here the point of intersection is origin, I guess.
huh, Okay, but sometimes or many times it happens. Suppose if the question comes in exam, then the students may not be having that much time to plot the graph exactly on a, because if we don't plot the graph on a graph paper, maybe we'll not be getting the exact point of intersection. So
Okay.
yeah, the question is how how we can find that exact point of intersection.
So instead of plotting the graph, how can we find out the limits you want to
Yeah,
say?
limits. Yeah, you're getting my point. Now, suppose if someone is solving this problem say in exam, and obviously we will not be having that much time to plot it on a graph paper.
Okay. So instead of plotting a graph, how to find out the limits? All right. From the given, we can find out.
Hmm.
So from here, 2x square minus 1 is 0. So let x square is equal to 1 by 2. So x is equal to plus or minus square root of 1 by 2.
Yeah. So means we'll solve. Yeah, we'll equate the two equations and then solve it. We'll get the points of intersection. Okay.
Yes.
Things are there. Okay. So like this is about the 11th and 12th, and the other things that in 11th and 12th they have that complex numbers.
Complex.
Yeah, the 3D is there. Even yeah, 3D is there, vectors and all those things. I think you might be aware of all these topics.
Yes. Yes.
And okay,
Even we
huh.
to the students as well.
Okay, and yeah, if we move on to the lower classes like 9th and 10th, they have a major part of mathematics for geometry also,
Okay.
like the triangles, their properties, the congruency of the triangles, the similarity of the triangles, the circles, the
Yes.
quadrilaterals, and all these sort of things. Are you familiar with these topics?
Yes. Yes. I'm familiar with.
Okay, so suppose if we have a triangle, right? In 9th and 10th, they have in 9th they have the topic on congruency of triangles. In 10th, they have the topic on the similarity of triangles. Can you tell me the difference between the congruency and the similarity of triangles?
We can use that properties, no? Sides, then side angle side, then what angle side angle.
Hmm.
That we can
No,
see congruence.
yeah, correct. Those are the properties or the criteria that we use to check whether the two triangles are similar or two triangles are congruent or whatever the question. But the question here is, what is the difference between the congruency and the similarity?
Similarity means exactly the same.
Hmm.
Sides angles are all similar, and the congruency means they are in proportion.
Okay, congruency means they are in proportion and all these things. And what about that commercial mathematics side? Like the questions on profit and loss, discount, percentages, ratios.
Okay.
Okay, suppose if I say there are three people, right? Say
Okay.
ABC. ABC are three people, and they have rupees 1800 with them, and they divide it in ratio 2:3:4.
In ratio
2:3:4.
2:3:4.
Yeah, how much 3 will get, or how much B will get?
Wait a moment, I'll just.
No, no.
B will get 600.
Yeah, 600. So these sort of things, they have the questions in commercial mathematics. Or suppose if the question is the selling price of an item inclusive of the sale tax is rupees 1200.
Okay.
and the sale tax is say 6%.
Okay.
What is the selling price excluding the tax?
Excluding the
Excluding the tax.
18.
Yeah, I'll just repeat the question. The question is the selling price of an item including the tax is 1200.
Okay, including the tax is 1200.
1200, where the tax is 6%.
Tax is 6%. Okay.
And the question is, what will be the selling price excluding the tax, that is without tax?
It is 1200 minus 72.
How you got 72?
It is 1200 multiplied by 6 divided by 100. 6% of 1200. I can minus that amount from 1200.
I think no, because this 1200 is the selling price after the sale tax is included.
Correct. So 1200 minus 72 is the selling price including the tax, no?
But the sale tax or the tax is always calculated on the base price. Base price is actually the selling price excluding the tax. Okay, no problem. So what I got to know from all this, like 11th and 12th calculus part and all is okay, but I think you need to go through the
Okay.
geometry part and the commercial part of the mathematics, because in lower standards like 9th, 10th, 8th, 7th, they have about 50% of their syllabus consisting of that geometry and commercial mathematics also. Okay.
Okay.
So yeah, in that part, I think you need to go through all these things. And nowadays, the books and all everything is available on the net. It's not like you have to buy the books and go through it. You can just go to, check the NCRT site, NCRT syllabus. You can check. And okay, this is one thing. And next thing is like only mathematics you are interested, or any other subject like physics, chemistry, any other subject?
Only in maths and a little about programming I can do it. C
Okay.
programming.
In programming, because in 11th and 12th they have I think C++ and Java. So
CPP.
uh,
Uh, yes, I am not sure with CPP and Java, but I surely I can take C. But they don't have C, then
okay. So for the time being, what we can do is like we'll update it for mathematics, and later on, if you feel like okay, you want to include like some other related subjects like physics, chemistry, or any suppose languages, say Hindi, English. So can include it later on also. It's not a problem.
okay.
Okay. So we'll end it here only, and then I'll just update it mathematics only till 12th standard. But one more thing I just want to repeat again. Please go through that geometry part and the commercial mathematics part,
Yes,
especially
yes,
of 8th, 9th, and 10th standard, because
yes,
they
yes.
have a lot of content for geometry and the commercial mathematics.
Okay, okay,
Okay, because the calculus part is there, it starts from 11th and 12th only. Till 10th, there is no calculus at all.
okay,
Okay. Okay, so
okay.
yeah, thanks. We'll end it here only. Okay, bye.